So the purpose of today is to wrap up our notes on passive transport, and we're also going to collect data and analyze the lab that we started yesterday. So for second hour, I realized that we didn't get to finish our notes on the different types of osmosis. So if you'll go ahead and get your notes out and open to this page, what we want to talk about are the terms hypertonic, hypotonic, and isotonic. And if you want to think about the lab that we did with the decalcified egg, when you put the egg in water, the egg expanded and gained mass. That's because the water rushed into the egg. So I want you to think about that. Was the solution, so the water on the outside of the egg, was the water hypertonic, hypotonic, or isotonic? So think about that for a second. So if there's just water on the outside of the cup, there isn't any solute. And then the egg, of course, has your lipids, your carbohydrates, your proteins, so it has a lot of solute. So the solution in the cup, the water, is hypotonic to the egg, and the egg then would be hypertonic. To compare that to the egg in syrup, yeah, your egg has a lot of carbohydrates, proteins, and lipids, but the syrup is very heavily concentrated in sugar. So it actually has more solute or more molecules within the water than the egg did. So the syrup would be a hypertonic solution, and then your egg would be hypotonic. So now let's look at the bottom of your notes, and let's draw an example of a cell in an isotonic solution. So these black dots are my solute molecules. So there's 1, 2, 3, 4, 5, 6, 7. Okay, so there's 7 on the inside, 7 on the outside. So in your pause, I want you to talk about, is that an isotonic solution? Is the solution right here isotonic yet? No, the solution is not isotonic, and here is why. If I took a sample of the outside solution and a sample of the cytoplasm of the cell, they wouldn't have equal concentrations of solute molecules to solvent. So in other words, if you want to look at it like a ratio. So when I draw my picture, I want to draw it so it looks like the same spacing that's occurring on the inside of the cell is occurring on the outside of the cell. So even though we have a lot more solute molecules on the outside of the cell, it's in proportion. So when you draw your isotonic picture, make sure that all of the molecules, both inside and outside the cell, are evenly spaced. Now I want you to look at this picture. Is the solution, so the outside solution, hypertonic or hypotonic? Remember, the prefix hyper means above concentration and hypo means below. So do we have more solute or less solute? You should be thinking less solute. So this solution is actually hypotonic. So that means the inside cell is hypertonic. So in comparison, a hypertonic solution will be overconcentrated, and your cell will be underconcentrated or hypotonic. And then this one here is going to take me a minute, so because you have to be really clear. In your pictures, you guys, make sure that you're drawing them so it's very clear that this is a hypertonic solution, overconcentrated. So when you look at your pictures, you should be able to see that the picture on the left, the hypertonic solution, is less concentrated and has less solute. In the picture on the right, the solution is hypertonic and has more solute or more molecules in the ratio, in the concentration, compared to the inside cell. Okay, so that's the end of our notes. What I want you to do is take a minute and see if anybody at your pod has any questions. And if they do, if somebody else at the pod can answer them and help explain them, great. If not, what I'd like you to do is go ahead and get out an electronic device, so grab your phone, and I want you to email me. My email is spelly, type it up here, spelly@Lindbergh Schools. Sorry. And email me those questions right now so you don't forget, so we can address them when I come back on Monday.